Okay, so now that we have our data table set up, and we have, whoops, what did there? We have our data table set up, so you can see here we've got our y-axis, our x-axis, which is our independent variable. We have our y-axis, which is our dependent variable. We could start putting data in. So let's just start putting that in. So let's say we'll go 1, and we'll say what the bug can eat, or the moth will eat 30 bugs per second. With 2, it can eat 60. With 3, it can eat 90. You see what Data Studio is doing over to the right. Is it's actually graphing as we go. 120, 150, and so on. So we have a nice graph here, and we can adjust the size of the graph. If you go down here to the x and y axis, you can shrink the graph in like this, or extend the graph out like that. So shrink it so it's all on one page. And what we say when we put data in, as scientists, we want to use what's known as a best fit line. Data is really observations. There's two kinds of data. There's quantitative and then there's qualitative data. Qualitative, quality, that's data that is an observation. It's a color or a smell or something like that. It's not a numerical piece of data. Quantitative data, though, however, is numerical, and it can be represented with a graph, and a graph is a picture of that. We often try to divine or glean a pattern from the data. This data actually has a very obvious pattern, right? We can see it's very linear. But what we might want to do, what I'll have you do a lot of times is find the best fit line. So to do that, you click up here on fit, and you go to linear fit if it's a straight line pattern. Now there will be some other patterns. We could have a quadratic pattern if it looks like a parabola. That's basically the other one we will use. But it looks like a line, so we'll do linear fit, and it'll superimpose a line onto our data. Now let's say we had so once it does that, it gives us the slope, which of course is the rise, the y, change in y over change in x, and it gives us some other, let's just go change a couple bits of data. So instead of 150, let's make it 140, and instead of 120, let's make it 100. It's a little messier. In real life, the data is never quite perfect. So let's say this is 80. So what we see is that we have two things going on here. We have, and I'm going to turn best fit off for now. We have our actual data where if you connected the dots, it would look like this. But what we really want is the best fit line, and it will attempt to draw a line that is closest to average for all those pieces of data, and that is what's important. Okay, the R value here, so we have our slope, and we have the y-intercept, right, of course, which is where the best fit line will cross the y-axis. But this R value, the closer it is to 1, the better our data. So 0.98 is okay. And we can see the R value, if we make the data a little crazier, we can see that the R value now is down to 0.856. And it's much harder to draw a best fit line. So that's why we use best fit lines. And the information gleaned from them is important. The slope will tell you oftentimes something very valuable, as well as this y-intercept can tell you valuable information. And that's how you find this information on Data Studio.